Let us clear the air. We have to fuel civilization. Everything from agriculture to industry, medicine to technology and transportation, even space travel. To do that, we must drill wells to reach hydrocarbons. However, we can do it smarter, better, and faster to reduce or even minimize our impact on the environment. That's what our world wants. That's what we want too. So we put our brightest minds on it. And that's where intelligent power management comes in.
Hello, everyone, and welcome to SPE Live. I'm your host, David Gibson. And for this SPE Tech Talk, we've got Schlumberger coming on board, and they're going to be discussing with us reducing emissions while maintaining optimal engine load. Some really important stuff. And so today, very, very special day. We want to be able to hear from you, the audience member. So first off, please let us know where you're watching from. Love to be able to give you guys a shout out as we're going through the show proceedings, as well as if this is your very first SPE Live or SPE Live Tech Talk to be able to watch, let us know. If you've seen some of the past, let us know how many and which one was your favorite. I'm guessing I might have been your host for that one. All right. So today's a very important day, and we are talking about hydrocarbons. Hydrocarbons are an important part of the energy mix and will continue to be in the future. The difficulty is in the process of extracting them as green as possible or being carbon neutral. During this broadcast, we will discuss the journey to achieve a carbon neutral well construction. Sorry, my glasses are falling off. One place we can start is with smart engine management. Joining me for this Tech Talk is Vinay Pemmasani, product champion at Schlumberger, who has held line and operations management positions in North Africa and the Middle East and Australia. I used to work there. Also on today's discussion is Schlumberger product champion Paul Wyman. Paul holds a bachelor's in chemical engineering and a master's in oil and gas management. Welcome to the SPE Tech Talk, and thank you both for joining us.
Hey, David. Happy and excited to be here to discuss a topic that we are very passionate about, decarbonizing the drilling process.
All right. Well, thank you, guys. Audience, let's see what you have to say. Send us your questions and reactions in the comments. Please, we want this to be interactive. That's why it's live. Otherwise, this would just be a podcast or some pre-recorded nonsense. You guys would never fall into the rabbit hole of watching. So interact with us. Ask the experts the questions. I'm not the expert. The other guys are, right? So there is a poll question on the LinkedIn event page. What percentage of overall oil and gas emissions come from extraction and drilling? Audience, your options are 2%, 5%, 10%, and 15%. Go to the LinkedIn event and answer the poll. We'll share the responses and correct answers later in this live stream. All right, let's get this conversation kicked off here. Vinay, why don't you set the stage with a quick overview of how upstream manages drilling emissions?
Yeah, sure, David. So before I start, like you said, right, hydrocarbons will continue to play a major role in the energy mix going forward, and it's imperative on the industry to meet those demand in a very sustainable manner, right? So that's what we're trying to do, is looking at various solutions on decarbonizing the whole the value chain of oil and gas industry. So you have a good poll question on what percentage of the emissions come from extraction and drilling. That's a really good question, right? So then you'll know what's the impact that we're having from just drilling and extraction. So overall, 8% of the global emissions come from oil and gas industry, between upstream, midstream, and downstream. A majority of this is from fugitive methane emissions, right? So there's various technologies that are there to deal with those. And then flaring, again, there's technologies today that can help you predict and do a zero flaring well, or at least minimize the carbon emissions if you have to do flaring. And I believe you have a tech talk coming up with Simon who'll discuss that on reducing carbon emissions for well testing and cleanup. So today we're going to focus on extraction and drilling, right? So the drilling process itself. So typically what happens is we tend to focus on optimizing or making the drilling process more efficient, thereby drilling the well in fewer days and therefore reduce emissions, right? So this is kind of let's do it, let's minimize the number of drilling days, and therefore we minimize the emissions. But what we are trying to do is get to the source of the problem, right? And that's what we need to do, because if you look at the entire the workflow of power on the rig, it's starting from the diesel to the bit. There's a lot of inefficiencies along the way, right? So let's start with the starting point, which is the fuel. It could be the diesel, natural gas, whatever it is. You start from diesel, then you go through the engines, and then there's massive losses there, right? So the internal combustion engine is not very efficient. You lose almost 50 to 60% of the energy of the diesel just moving from the fuel to the mechanical energy. And then there's another 5% loss moving from the mechanical energy to the electricity, right, from the generators. So this is a very inefficient process just on the first step, right? So what can we do to make it a little bit more efficient? And even after the electricity is generated, are we using it efficiently, right? So we know in most cases, let's say you need to run 2 generators at 80% load. What typically happens is you're either running 3 generators at 50% or 4 generators even at 40%, right? This is just how it's been done. It's more safe. You don't want to get into a blackout situation. But can we do something so that you use exactly the number of engines that you need, and thereby you minimize the emissions, right? So this is just the power getting from the diesel to the generators, and then there's more. Now the power is being consumed by the equipment, and similar philosophy here, right? So we know that the mud pumps, top drive, and drawworks consume the most power on the rig, but then there's all these auxiliary equipments which mostly run all the time, right? Do we need to run them all the time? Probably not, right? So we'll have to look at how do we turn these off, how do we bring them back on when it's required. So all these small things add up to reducing the emissions of the drilling process, right? And finally, once it's available at the equipment, goes to the bit through the drill pipe, and there's losses there as well. And that has been the focus most of the time, is how do we make that process very efficient? How do we make it make the drilling process more efficient and do it faster so we reduce emissions? But we'll have to look at the upstream, which is the power supply side, and then the demand of the equipment first, right? And then one more thing I want to add before I pass it on to you is, can we have all this information fed to the drilling engineers and the well engineers when they design the well, so that they're cognizant of the carbon footprint, right? So if you choose option A, this is going to be your carbon footprint. If you choose option B, your carbon footprint is going to be 20% lower. Can you design the trajectory in such a way that you're minimizing the impact, right? So all these things have to be taken into account, not just drilling efficiency, and that's what we're doing. And intelligent power management focuses on the power supply and the demand of the equipment.
Wow, that's definitely a lot to be able to take in there. All right, so before we get too far, let's take a look at the poll. All right, so our option choices, once again, were 2%, 5%, 10%, and 15%. And looks like we got goose eggs for both 2% and 10%, while 5% and 15%. So if it had the number 5 in there, somehow people voted for it a little bit more, right? The correct answer is 10%. 10%. All right, Vinay, Paul, give me your reaction, guys, to that.
That's typically about what we see as a response. I mean, in the end, we end up 10% or so on the emissions that we see to the environment from the drilling process. But yeah, I mean, it's oftentimes we'll see people guessing fairly low on that, but it's quite a significant amount, to be honest.
So while 10% may sound like a small fraction, it's still a significant amount. So how are engines being managed today, and what can we do to make improvements?
So one of the things that we're looking at when it comes to how we manage the power on the rig is from multiple different fronts. The first is, how do we produce the power? The second is, what is consuming the power, and are we consuming that power in the most efficient way? So I'll touch on each one of these individually. When we look at producing the power, typically on most oil and gas rigs around the world, whether they're onshore or offshore, are powered by engine-powered gensets. These can range anywhere from 3, some rigs have 5, some rigs have 6. They are all managed together, so they typically share a load across them, and whatever the load requirement from the rig, depending on the operations, will determine what load and how much power is output from those generators. Because the rig is operating in a very dynamic way, oftentimes more engines are kept online to be able to provide enough power, for any peaks and surges that we might see, so we don't find ourselves shutting down the rig due to a lack of power or reducing the performance based off of more demand than what we can provide. So from a power generation perspective, we want to be able to manage the engines in a way that we can put them in their optimal load state using the fewest amount of engines. And then, going one step further is to place the load on the specific engines that are going to not only give us the best performance as far as power production, but also, increasing longevity of those engines by managing and biasing where we're going to, which ones we're going to be using. So that's the power generation, and by simply just managing the engines smarter by turning them off or on when we need certain engines or a certain amount of power for specific operations, we can save anywhere between 10 and 12% in our emissions that we're seeing. We then go one step further by introducing a battery storage technology. We're looking at a wide range of battery materials, from lithium ion to nickel zinc to nickel hydrogen. Depending on the application, some of those different types of chemistries will be better suited for the environment. But by adding that battery storage in, we now give additional flexibility to us managing the engines and managing any of the peak periods of energy consumption on the rig. So by doing that, we can then take that 10 to 12% and then expand that even further to where we've modeled up to 25, 30% reduction in emissions. So that's one key piece, is setting that foundation, putting engine management through a pretty significant algorithm that we've built, adding in battery technology, and then once that foundation's in place, we can start to bring in additional power sources, whether they're fuel cell technology, it could be utility highline power, it could be solar, it could be regenerative power. We're able then to introduce all of that into the equation on the power generation side and manage all of those sources depending on what the needs are on the rig. So that's one side of it. The other side is truly understanding what the consumers on the rig are. So what is a drawworks consuming? What are the mud pumps consuming? What are the overall power requirements to light and have the rig function? We, by better understanding those, will be able to manage from the consumer side, maybe how much they're being used, whether they're on or off, the typical load that we're pushing through them. And then so seeing the overall picture from both the power production and the power consumption side, we can then manage all of that together to place the rig in the most optimal state to produce the power when it's needed and how it's needed on the rig to reduce fuel consumption and emissions to the environment.
That's a lot to be able to take in, especially with all the different things that are running at the rig, especially the AC and the MWD and directional drilling shack. This is probably a question for both of you. Tell us about some case studies and initial results in this space. Looking to hear what you have to say about getting to zero carbon drilling.
Yeah, I can start on this. So we've been doing extensive testing of our technologies for quite some time, and like Paul said, with the intelligent software, we're seeing somewhere between 10 to 12% of emissions reduction, right? Just with the software, and then you add in the energy storage, which is the battery in this case, then we're seeing somewhere between 25-30% reduction in emissions. So just to add, right? So all these technologies that we were talking about today, they play a role in minimizing the inefficiencies along the system, right? But the ultimate goal is to replace the hydrocarbon fuel that you're using, because even whatever we do, there's still going to be some fuel that's going to be burned. There's still going to be some emissions that are going to go out to drill the well ultimately, right? So the only way we can go full zero carbon emissions is by replacing the fuel source and with a non-hydrocarbon like hydrogen, ammonia, ethanol, and so on. And we are particularly interested in hydrogen, and we're working on a solution to use fuel cells to power the rig, for example. Paul, would you like to add something?
Sure. And I think, when we look about case studies, and a lot of it comes down to what is the effect of introducing this intelligent power management. And there's actually a good question that's come from Sunny here, who's asking, when we reference these different gains, whether it's 10, 12%, 25, 30%, what does that mean in relation to the baseline on a rig? And so is it for specific activities, or is it average over the well? And so I think that's a really good question, because every rig right now is managed very differently. Some rigs actively manage their engines and are very conscious about how they're powering their rig. Others are not. And so what we typically will do is we will look at a baseline of data over a certain period of time, whether that's 3 months or 6 months, and we'd like to see it over several wells. We then break that down even further into specific operations to try to understand power consumption requirements through, say, the tripping phase or drilling, or maybe if they're doing their BOP tests, or maybe even when they're stuck and they're trying to fish a tool. The more and more that we can understand how the power is consumed in these individual times and individual instances, will allow us to set the power generation systems at the rig up to provide the most optimal power. This takes us sort of to our next development within our software, is having the ability to get a bit more predictive in what's coming up. And so if we can start predicting what event is about to occur, say we are drilling ahead, we know we're going to be TDing the well in the next couple of hours, and then we're going to circulate, clean out the hole, and then come out through a trip. By doing that, we can start to set up the engines and the batteries or whatever power sources that we have at the rig to be able to respond to that specific type of operation. So all of our numbers are typically referencing a well or a period of time, 3 to 6 months, that we're evaluating things, but we are looking at a much more discrete interval to really understand what's going on as far as the dynamics.
Wow, I mean, obviously it's very interesting to hear that you guys are studying the rig for a 3 to 6 month time period to be able to implement some of these new changes. Right. All right. Audience, now is a good time to go ahead and start typing your questions into the comments of the stream. We'll begin working over some of those shortly. You saw just a minute ago, we answered Sunny's question. So put your question in. You might have your name and picture up on the screen, and we'll answer yours as well. It's the whole point of doing this live, like I said. All right, Vinay, what future plans are you exploring specifically with decarbonizing the rig and well construction process? I guess a big question there is it possible to drill an emission-free well and be cost efficient?
Yeah, so that's a good question, David. So there's two pieces to it, right? One is the decarbonizing the rig power, which contributes most of the emissions to the drilling process, and then the second thing is how do we to manage the waste, the cuttings waste, for example. How do we minimize the cuttings waste that are coming out? How do we introduce technologies in the manufacturing of the mud so they're much more cleaner and greener than they typically are, right? So to address these two questions, the first question is how do we drill emissions-free well cost effectively? It's going to be a challenge today, but then we've seen how PV and the solar PV's prices have dropped, and then with the support of the customers and some regulatory pressures, this can be very attractive pretty soon, right? So to meet the target, it has to our climate targets. It has to be a very collaborative effort, and between the drilling contractors, operators, service companies, governments, the regulating bodies, all of us have to work together to make it happen. So it is possible, to answer your question, it is possible to drill a green decarbonized or emissions-free well. in a very cost-effective manner. We're working on the economics, and we think it's fairly in the next 3 to 4 years it'll be really possible. And then we have to start at some point, and then we'll slowly reduce the cost as the economics play out. But you could always start at, let's say, 50% reduction, 60% reduction, and then you can slowly reach your zero emissions target. On the other topic of, can you make the mud greener? Can you minimize the waste? Again, there is technologies that today are cost effective and in fact saves you money by using those technologies to reduce emissions, right?
Excellent. All right, so we did get a question here into the comments section. Pull this over so I'm not having to look off screen to be able to read this. So as far as Mahamud, I'm sorry if I butcher your name. You just have to understand I'm terrible at reading, right? I'm good at hosting, not reading. Okay, so he did say he's watching from Lafayette, Louisiana, so at the very beginning of the show. So thank you for that. So his question is, how is the industry taking the transition to cleaner energy initiatives, specifically for U.S. land market? How are operators and drilling contractors reacting to the change, the old way, and energy transition? Great question, because we know that, like, U.S. land versus the rest of the world can be two completely different markets, where a lot of the international deep water stuff is headed up by large multinational companies who have a large public presence, right? Versus, Tim, Steve, and Jennifer, who have a drilling rig out in West Texas, and they're only drilling a one well program. How is that energy transition taking place in U.S. land from y'all's eyes?
So, it's been very positive. So we've got a lot of interest from both drilling contractors and operators when we bring up this topic. Everybody's excited. Everybody wants to take a part and do something about it, right? So, like I said, if there is outside pressure, either from the government, there's incentives, carbon credits, carbon tax, etc., then the transition happens much faster, right? Because there is an economic incentive today to make it happen. In case they're not there, then it's up to us. It's up to all the parties to work together and see what makes most sense. Because at some point we know it has to be done, right? So it's either delayed by a couple of years, but it's going to come. So we'll have to be prepared. We can't just wait for the economic incentive to show up. We can design today. We can probably model some commercial models to make it economically attractive to our partners. So to answer the question, there is no resistance, in fact, to doing the old way and moving to the energy transition. There's a lot of interest, and we've been talking to a lot of customers in the last six months, and everybody has shown a lot of interest. And I think we will, by working together, get to a future where we are able to drill and wells with less and less carbon footprint, and ultimately even reach the zero carbon footprint well in U.S. land, to be honest.
So a question for me here is this like a two-pronged approach? Because obviously you guys talked about the actual drilling process. So is shaving days off the well plus the engine management, are both of those helping equally? Is that kind of the mission there between yourself and I guess some of the other parties within Schlumberger to be able to get the overall goal?
Sure. David, I think when it comes down to the overall drilling process, there's a lot of things that we can do to shorten the time and to do things much more efficiently. And that will certainly add to what we see for the reduction in the overall emissions. When it comes to something like intelligent power management, the benefit that we're seeing and the acceptance by a lot of our customers to want to get this technology out onto the rigs is it provides them a way to directly measure their results. They can see from a reduction in their fuel that they're burning on a daily basis. We can directly measure the emissions coming from the stacks at the engines. We can show those actual empirical results and provide that feedback to really give them the understanding that they are reducing their emissions specifically from a direct way of burning whatever fuel they're doing. It also has the added benefits of allowing them to extend out their maintenance windows on their generators, so reducing the amount of maintenance that they have to do because we're managing those engines much more efficiently. So things like that are what the operators and the customers that I've been interacting with are very perceptive to and want to see this new type of technology come out to their rigs, because they see some of the side benefits as well as what they're going to see from their emissions reduction. So overall, it's been a very positive experience, and we're looking forward to seeing a lot more of our systems going out onto rigs in the future.
So how does it feel for you guys to be a part of this and to see, the results of it? Like you said, you guys are able to measure this. How does it feel for you guys when you guys see the result of one of the wells where you guys have implemented some of your solutions on and see phenomenal progress?
So it feels really good, right? So I mean, like I said, we're really passionate about decarbonizing the drilling operations. To your previous question, right? There's various pieces within Schlumberger that are working towards this common goal of being net zero by 2050 with minimum reliance on offset. That's our target, right? And we have 2025 and 2030 targets as well. So by bringing our technology and then being able to reduce the emissions at the source of the problem, which is where the power is generated on the rig, is really exciting to see. And then once you see the results and you're monitoring the emissions, which is again a challenge today, right? There's no direct way of measuring, and we're trying to come up with technologies to directly measure the emissions, make it real time, and then compare it with the baseline and see and show the difference that we can create with these technologies just by targeting the source of the power and then ultimately replace the source. So I'm very excited.
I'd love to be able to be there at the office that day when you guys are giving each other high fives and stuff. So looking a little bit closer, like what you just said there, what advancements are needed in emissions monitoring to be able to help bring the solution even further?
Do you want me to take that one, Vinay?
Yeah, sure. Go ahead, Paul. You've been working on that.
Right. So, what we're looking at when it comes to the emissions monitoring is direct measurements that we can get from the stack. So bringing out a number of sensors that allow us to measure carbon dioxide, carbon monoxide, NOx gases, some different volatile organic compounds. So we're looking at a number of emissions that we can directly measure, and then we can take that data, see the results, see the performance of how our system is running. But in the end, we're going to be feeding that data back into our algorithm with the idea that we're going to then further optimize or further manage the engine power generation to in the end optimize and reduce the emissions as much as possible. So just by measuring the emissions at the well site is going to give us that tangible data to confirm this is what we're actually seeing for reduction. It gives you that real good feeling that, hey, I can actually measure what we're reducing as far as emissions, and then taking that data and then bringing it back around in a closed loop system to further enhance our system and our intelligent power management.
Wow. Well, this broadcast has flown by, and I know there's probably tons more questions out there. I know I could probably ask you guys questions for probably another hour. But here in closing, both of you guys, give us your closing thoughts and what's the best way to be able to get in touch with you after the show.
So the best way to get in touch with us is either through LinkedIn, or you can email us. Get in touch with LinkedIn, and we can carry on this discussion. It's a huge topic, like you said, David. We can keep talking about this, right? So on closing thoughts, what I would say is, like I said before, it's going to be a collaborative effort, right? I mean, we'll all have to work together to make this climate change, the climate target, a reality. The drilling contractors, operators, the service companies, communities, all of us, right? So we'll have to do it for the community, and then as an industry, it's very good to see that we are evolving and we are trying to get greener ourselves. So that's my closing thoughts. Very excited to see where we go.
And Paul?
Yep. So my closing thoughts are very much in line with Vinay. We're very excited. What I really love to see is that technology is evolving in a way that's really allowing us to expand what our capability is at the rig to be able to reduce emissions. So we're going to continue with that effort to keep moving forward on the technological front, and very excited about introducing these technologies to the market.
Well, I'm very excited to be able to hear about this. This is some great stuff for our industry and, as you guys said, also for our community. All right, for everybody out there watching, please be sure to continue the conversation here on LinkedIn or any of the other social media outlets that you like to use. SPE is on all of them. Check us out on YouTube, LinkedIn, Facebook, Twitter, Snapchat, whatever. All of them are out there. But feel free to like, share, subscribe on all of those. Thank you for watching this SPE Tech Talk. Please stay tuned. We've got another one the same time tomorrow. And as I always like to say, know your industry. See you guys next time.
Smart drilling is all about digital. It's about live streaming real-time data from the tip of the drill bit to the joystick on the driller's chair and beyond. We provide a digital ecosystem that displays real-time data from the well site, enabling faster decision-making and troubleshooting. Digital capabilities fuel surface automation, which brings new solutions to ongoing customer priorities. We deliver fully integrated systems, backed by a century of experience.